Alright, hey everyone. Today I'm going to be doing a lesson on cylinder investigations. So what I have here, the supplies I'm using, I have two things of dry rice. These are both halves of the construction paper. This one is, the taller one is, the diameter is 1.5 inches and the height is 9. And then this one, the diameter is 2.5 inches and it's 6 inches high. So basically, these are both made out of halves of the construction paper. So we're going to see when we fill these up if they hold the same amount or different amounts. And we're going to determine why. So because these are made from the same halves, the same construction paper, you would think that they're going to be the same in how much you put in it. You would have the same amount in each. I'm not sure yet. I mean, I did this on a different one, so I kind of have an idea what's going on, but we're going to see what happens with this. So I'm going to just basically do the experiment, and then I will go over the math with you to show you exactly why we got what we get. My prediction before this was that they would both have the same because they both the papers that we used were, or that I used, were the same height, same width, same everything. So we're going to see. I'm hoping it doesn't get too messy because this thing is very small, so then I'm going to have to use this guy, and that's probably not going to go too well, but we're going to see. So what we're going to do is this is straight from the textbook too. So we're going to take this and we're going to put the longer one in here, and then we take this and we pour it right into the longer one. When this one is full to the top, and I'll show you when we get to that point when it's full. When this one's full to the top, then we will take it out and we're going to see how much of this one is full. So if you're assuming that, if your hypothesis is that they're going to have the same amount, that means that this one will be filled to the top once this one is taken out. So we're going to see. So we'll start by pouring this one in. And again, this might get messy, so I'm hoping it doesn't, but we're going to see. Alright, so that filled up about halfway, so we have to use this big guy now. Let's see if we can do this. Here we go. A little more. Alright. So I'm going to pull it up. So this one is basically filled to the top. So that's the top. And we really didn't get much into the other cylinder, so we should be fine. So now that we have that, sorry, my hand got in the way. So now we have that. Now the next step is we're going to pull this out, and we're going to see, is this going to fill up, not fill up at all? We're going to see, is it going to overflow? So pull this up. Did not tape down, so, yep, okay. Alright, cool, so if you look, again, sorry, if you look, this only has filled up to about right here. So that's a little more than halfway, and this one was not taped very well, so really it's going to tape about halfway, a little more than halfway, so that's pretty good. So if you predicted that it would fill up to be the same, then, well, that might just be because of the math, and I did the same thing, so don't worry about it. But now I'm going to show you exactly why this is the case. So, and this is an easy thing, you know, it took me 10-15 minutes to set up, and then I tested it using these cards. These were 5x8 index cards, which is the ones that the textbook used, but I wanted to get a bigger sample because obviously these are two very different things. So I wanted to get a bigger sample for it. So to show you, I used construction paper. So now this is where it's going to get tricky. Let's see. Alright. Okay, so, and I'm using my phone for this, so this is a little bit difficult. So the formula for volume is V equals pi r squared height times height. So basically, if we look at this long one first, let's see. So we look at the long one first. the formula is V equals pi 0.75 squared times 9, which would get us 0.5625 pi times 9. And then when we multiply 0.5625 times 9, we get 5.062, and multiply that by pi, and you get 15.904. So I'm just going to do it like this. So this is the math here, obviously. And now if we look over at this one, it's the same formula, same everything, but if you look down here, our result was 29.452, and I used a calculator for this. I did all the math on the calculator, so this should be right. Everything on here is the same formula, same everything, except this one is almost over halfway, two times as big as this one. So the reason for that, sorry, this is very hard to do. There we go. So the reason for that is when you take the diameter of both of these cards, they are both very different. So the diameter of the long one was 1.5. So when we're doing the radius is half of the diameter. So that means that the radius was 0.75, and when we square 0.75, we get 0.56. So when we get, because it went smaller, when we multiply by 9, when it only went to about 5, and you multiply that by pi, and it's about 15. When we did the diameter of the smaller one, I'm not going to pull it out. Okay, this one, still rising, so I'm not going to move it. When we did the diameter of this one was 2.5 inches. So when we have that, the radius was 1.25. So when we multiply 1.25 times itself, we got 1.5625. So that led us to, when we multiplied by the height, even though the height was 3 inches less, it still got us a higher number that we can multiply by pi, which was 4.908, and I'm sorry, that we multiplied with pi to get to 4.908, and then we multiply by 6, which gets us to basically 29.5. So the difference was about 14. When I did this math with the smaller ones, which I have over here, this one was a little messier. When I have this one over here, again, you see the size difference between these two. This was the wider one, and this one was a bit better because they were taped up a little better, but this one almost went a little less than halfway, and the math for this one ended up being so that this was more than 2 times the size of the long cylinder. So yeah, that's basically it with that lesson. So the radius has a big impact on the volume of a cylinder. As a matter of fact, it's probably the biggest indicator, because there's a 3-inch difference from height in the long cylinder to the wide cylinder, and it didn't make a difference because the wide cylinder, even though it was 3 inches shorter, still had another 50% to go that it could fit the rice in. So yeah, that's basically the lesson. Hopefully everybody enjoyed it. Let me know how I did, I guess. Yeah, but that's basically it. Thanks.